Okay, this is the P1 paper from June 2024. This is question number 11, and as we can see as I pan down, this is a trig ratios question. In particular, we're going to be looking at the graph of sine x and transforming that graph. So let's have a look at the question, and the question says, figure 4 shows a sketch of a part of the curve C1 with the equation y equals 12 sine x. Measured in radians, so not degrees. Don't make mistakes of using the wrong units on our axes. It says point P is shown in the figure. Yeah, I can see that one there. What are the coordinates for it? So the first thing I notice is that we have a 12 here. So if we have a 12 here, we're doing y equals a lots of fx, and multiplying a function by a is going to mean that the function is going to stretch scale factor a parallel to the y-axis. Let's get rid of all that. In terms of sine x, then, we now know that instead of these values being being 1 and minus 1, they are now 12 and minus 12. That function, that transformation, has no impact on the x-axis. So the x-axis is going to stay the same. And we know that for sine x, this would be 0, 90 or pi over 2, 180 or pi, and keep going then. So this value is 3 pi over 2. This value is 2 pi. Just quickly, that's one complete period of the sine graph, but we keep on going, adding on pi over 2 as we're going. So that means that this one works out to be 5 pi over 2. So if I want the coordinates of P now there, I can see that that's 5 pi over 2, 12. So we're not going to put that there. We're going to put that as our answer. Let's cut that and put that all the way down here. So part A, give the coordinates of P. Yep, so P is equal to 5 pi over 12. Okay, first part done. Second part says, the curve C2, so a different curve, has the equation y equals 12 sine x plus k. So if I've got f of x plus k, I know that what happens there is that the whole graph moves up by k units. It says the new maximum value of y on C is going to be equal to 3. So we need to think carefully about this one then. My original graph is this one here. I'm just going to go over this because I'm actually going to move it using the iPad. That once I move this up by k units, the new maximum point works out to be equal to, maximum value is 3. Well, if I look at that, it means that I can't be moving it up by any number of units. And actually what I want to do is to move this whole graph down to the point where this value now, this maximum value here is 3. So I can see that I've moved that down by 9 units. This would now be at minus 9. This value here would now be at minus 21. Everything has moved down by 9 units. And in answer to, it says, if that's true, find the coordinates of the minimum point on C, which has the smallest positive x coordinate. Okay, that'll take some unpicking here. First of all, we understand that k is going to be equal to minus 9. If k is equal to minus 9, then I now want to find my minimum values. So my minimum values on the original graph were here and here. Which value is it talking about? It's not talking about that one because that has a negative x value. So when we're trying to just unpick this part here, the minimum value which has the smallest positive x coordinate in the original graph, that's the minimum value which has the smallest possible x coordinate. We're now saying what's happened to that when that value is on our new graph here. So on our new graph, it's 3 pi over 2 minus 21. Let's say that to the examiner. So for part B, I would say if new minimum equals 3, then k equals minus 9. Okay, if k is equal to minus 9, what point have they called it? They've called it minimum point on C2. So the minimum point on C2 is now going to be given by, as we just said, 3 pi over 2 minus 21. Okay, on to part C. We don't like these trig graph particularly, but this one hasn't been too bad so far. So it now says curve has the equation y equals 12 sine x plus b. So we're now doing f of x plus b inside the brackets like that, and hopefully you all realise that means that we're going to have a translation in this direction, in the x-axis, and when these transformations are inside the bracket like that, it does the opposite of what I would expect to do. So this is all going to move by b units to the left. This is going to be a translation 0 minus b. So let's go back to our original graph. Let's get rid of everything off of it. And let's make that a little bit bigger so that we can see it. So what we're saying then is our original graph was 12 minus 12 here. And now what we're saying is if we now do a transformation, again, let's just draw it so I can move it. If I have this as my original graph, and then what I'm going to do is I'm going to translate this certain number of units across. Let's go back to the question. So the question says that this time b is a positive. So if b is a positive, I knew it is going to move to the left. And it says my new minimum point is pi over 4a. Pi over 4a. So let's go back to the graph and say that when I do move this over, I'm going to move over to a point. I could keep moving, actually. I could try and get it as accurate as I can possibly have this to be. This new point is going to be minus pi, sorry, it's going to be pi over 4. It's going to be pi over 4, and it's going to be pi over 4a. So the new point is going to be pi over 4a. And what they're going to want to know is what's a and what's the possible value of b. Well, let's do a first of all, because a is fairly straightforward. When I've moved that point over now, it hasn't made any difference to the y value. So my new point is pi over 4 minus 12. I can see that that's going to be the point pi over 4 minus 12. So a is going to be equal to minus 12. Let's go and put that in. So for part C, a is equal to minus 12 because there's no change in y direction. And then what about the value that b is? Well, what have we got? We've got our original point over here. If I put the graph back for a second, let's just get rid of some of this stuff that I've been doing. This graph was all the way over here at 3 pi over 12. And what I've now done is I've now moved it to the point where it's over there. So it's moved this distance here, hasn't it? It's moved the distance from 3 pi over 2 to pi over 4. So if I want to work out what that distance is for b, we've just got 3 pi over 2, the difference between 3 pi over 2 and pi over 4. And if you work that out on your calculators, that works out to be 5 pi over 4. Well, as you can imagine, a trig graph question being the last question on the exam is going to be a little bit challenging. You might need to look at that video a couple of times, but hopefully after you've seen it through a few times, hopefully that'll all make sense.